Fortunately, there are several excellent and freely available compilers to choose from. One of the most popular and widely used is GCC, the GNU Compiler Collection. GCC is a versatile compiler that supports multiple operating systems, making it a great choice whether you're working on Windows, Mac, or Linux. Its cross-platform compatibility is a significant advantage for developers. Another excellent option, particularly for Mac users, is Clang. Clang is known for its speed and efficiency, and it's often the default compiler on macOS systems. If you're on Windows and want to use GCC, a convenient way to get it is to install MinGWW64. This provides a complete development environment, including GCC and other essential tools. For Mac users, the Xcode command line tools offer a straightforward way to access Clang and other command line development utilities. It's a lightweight alternative to installing the full Xcode IDE. On Linux, installing GCC is typically as simple as using your distribution's package manager. For example, on Ubuntu or Debian, you can use the command to install GCC with ease. Once you have a compiler installed, the next thing you'll need is a text editor. This is where you'll actually write your C code. While basic text editors like Notepad on Windows or TextEdit on Mac can technically be used, they lack many features that can significantly improve your coding experience. That's where code editors like Visual Studio Code come in. These editors are specifically designed for programming and offer a wide range of helpful features. Sublime Text is another popular choice, known for its speed, customizability, and powerful features. Atom, a text editor developed by GitHub, also offers a rich set of features and a vibrant community of users and developers. Take some time to explore the available options and choose the editor that best suits your needs and preferences. Once you've made your decision, download and install your preferred editor. With both a compiler and a code editor installed and ready to go, your C programming workshop is now fully set up and prepared for action. You've laid the foundation for your coding endeavors. You're now fully equipped with the essential tools to start coding in C. You have everything you need to write, compile, and run your own programs. Now that we've covered the necessary setup, let's move on to the exciting part: writing your very first C program. The tools are all in place, configured, and ready to be used. It's time to put them to work and start building something amazing. It's time to put your fingers to the keyboard and start writing some code. Get ready to bring your ideas to life through the power of C programming. Prepare yourself for the journey ahead as we embark on creating your very first C program. It's a significant milestone in your programming education. So, without further ado, let's begin this exciting adventure into the world of C programming. Every programmer's journey begins with the classic Hello World program. Its job display, Hello World, on the screen. This simple program proves your setup works and introduces the process of writing, compiling, and running C code. Open your code editor and create a new file named. Type this code, save the file. Open your terminal or command prompt. Navigate to the folder with and compile with. If there are no errors, run your program on Windows, type on Mac, Linux, type, you should see, Hello World, on your screen. Congratulations, you've written and run your first C program. You're officially a C programmer. This is just the beginning. Next, let's break down what this code means. Let's look closer at your first program. Onward. Alright, let's dive in and understand the fundamental structure of a C program. We're going to break down the Hello World program line by line, so you can see exactly what's happening under the hood. This is crucial for building a solid foundation in C programming. Understanding the structure is the first step towards writing your own programs. Let's take a closer look at the anatomy of your Hello World program. We'll dissect each component, revealing its purpose and how it contributes to the overall functionality. By the end of this, you'll not only know what the code does, but also it's written that way. This understanding will empower you to modify and extend the program in the future. The line brings in the standard input-output library. This library is a collection of pre-written functions that handle common tasks like displaying text on the screen and reading input from the keyboard. It's a vital part of almost every C program. Think of it as a toolbox filled with essential tools for your programming projects. This gives you access to functions like the function defines the main function, the heart of your program. Every C program starts its execution here within the function. It's the entry point, the place where the operating system begins running your code. Without a function, your program wouldn't know where to begin. The curly braces and mark the beginning and end of the function's code block. Everything inside these braces is part of the function and will be executed sequentially. They define the scope of the function, indicating which statements belong to it. The statement prints text to the screen. It's the instruction that actually displays the message. The new line character moves the cursor to a new line after printing the text, ensuring that any subsequent output appears on a separate line. It's a simple but important formatting tool. The statement signals successful program completion to the operating system. A return value of 0 typically indicates that the program ran without any errors. Every statement in C ends with a semicolon. Think of it as a period in a sentence. It tells the compiler where one instruction ends and the next begins. Forgetting a semicolon is a common mistake, so always double check. This structure is the foundation for all C programs, no matter how complex they become. Understanding these basic building blocks is essential for mastering the language. Now you know what each part does and how it contributes to the overall functionality of the Hello World program. Understanding this fundamental structure will help you write more complex programs in the future. It's like learning the alphabet before writing a novel. Next, let's learn how to store and use information in your programs. We'll explore the concept of variables and how they allow you to manipulate data within your code. Time to meet variables, the fundamental building blocks for storing data in your programs. Let's move forward. You're building real programming skills with each step. Keep practicing and experimenting with the code. Keep going. You're doing great. Programs become powerful when they can store and work with changing information. Variables are like labeled boxes for storing data. Before using a variable, you declare its type and name, like common data types, for whole numbers, for decimals, and for single characters. Assign a value with, for example, use variables in your code, such as printing, is a placeholder for an integer in. Choosing the right data type helps the compiler manage memory and data correctly. Variables let your programs remember and use information. Next, let's see how to do calculations with them. On to operators. Let's continue. Now let's perform calculations with variables using operators. C uses familiar symbols for addition, for subtraction, for multiplication, for division. Example: print the result. C follows standard math order. Multiplication, division before addition / subtraction. Use parentheses to control order, is different from. The modulus operator gives the remainder is. Modulus is useful for checking if numbers are even or odd. These operators are the building blocks for all calculations in C. With operators, your programs can solve real problems. Next, let's make your programs interactive. Let's get input from users. You're making great progress. Let's keep going. On to input and output. To make your programs interactive, you need input and output. Output uses, as you've seen. For input, use from the library. Example, ask for age. The before tells where to store the input. After input, you can use the value. This combination lets you create interactive programs. Now your programs can talk to users. Next, let's add decision making. On to statements. Real programs make decisions using statements, and statement runs code only if a condition is true. Example, check if someone can vote. The operator checks if age is 18 or more. The block runs if the condition is false. And make your programs smarter and more responsive. Now you can control your program's flow. Next, let's repeat actions with loops. Time for loops. Let's continue. Loops let you repeat code efficiently. The loop repeats as long as a condition is true. Example, print numbers 1 to 5. The counter increases each time, stopping when the condition is false. Without updating, the loop would run forever. The loop is compact for known repetitions, combines initialization, condition, and update in one line. Loops are powerful for automating repetitive tasks. With loops, you can make your computer do more with less code. You've learned the basics of C programming. Keep practicing and experimenting. Your journey as a programmer has just begun. Congratulations. Keep coding and exploring. The world of C is yours to discover.